Good morning students. In the previous class we completed the first exercise. Now we move the second exercise. We already tell what is meant by a discrete and a continuous random variable. The second exercise is fully a discrete random variable. That is, the values of the random variable are countable is called discrete. Now we see first of all some basic concepts and also some basic formula relevant of a discrete random variable. You know very well every total probability value is always is equal to 1. In lower class also we see the total probability value is 1. Now we see some concepts. An important formula regarding a discrete random variable. You know the probability mass function. First we see one function. The name of the function is a probability mass function. That is, some random variable is there. To find all probability value of the random variable, then we write all in one box. This function is called a probability mass function. The symbol of probability mass function is a smaller type of x. It's very important. There is a difference between a smaller type of x and capital type of x. A smaller type of x indicates the probability mass function, and a capital type of x indicates the cumulative distribution function. And also it is p of capital X is equal to small x. So we say in two manner, either smaller type of x or p of capital X is equal to small x. The total probability value is 1. That means, what is the name of the symbol? Summation. Summation of f of x always is equal to 1. X value start from suppose minus infinity to up to plus infinity. This value of x is start from suppose minus infinity up to plus infinity. Or if it is a discrete, the value of x is suppose is either or summation of x is equal to 0 to 2, f of x is equal to 1. So this value is also possible. In general, I write summation of f of x dx is equal to 1, or summation of x value start from 0 to 2, all total probability value should come 1. Next, we move the next one is a cumulative distribution function. The symbol of a cumulative distribution function is a capital letter f of x. This is important. Probability mass function is small f of x. And a cumulative distribution function symbol is a capital f of x. And the formula of capital f of x is p of capital X is less than or is equal to small x. For example, I say one example. It is actually the general formula of capital f of x is p of x is less than or is equal to x. Suppose in a sum, we want to give one example. The random variable x can take a value from 0, 1, 2, 3 like this. I assume x can take these 4 values. Suppose we find f of 1. You see here, in place of x, I substitute 1. So p of capital X is less than or is equal to exactly the value of x is 1. So p of x is less than or is equal to 1. That is the probability of the random variable x. That value may be 1 or less than 1. So what is the chances here? What is the less than number of 1 here? 0. So there will be 2 chances. So either p of x is equal to 0 or p of x is equal to 1. We already tell probability r means plus. So x is less than or is equal to 1 means the value of x it may be 0 or it may be 1. Suppose I write here 2. So p of x is less than or is equal to 2. That means the value of x is 2 or less than 2. So what is the total chances? It may be 2 or 1 or 0. So this is the concept of the cumulative distribution function. And to find f of x when capital F of x is given. To find f of x means the smaller f of x is a probability mass function. In shortcut form, we say it is PMF. That is a probability mass function. When capital letter f of x is given, capital letter f of x is given a cumulative distribution function. In short form, we say it is CDF, cumulative distribution function. To find a probability mass function, suppose the cumulative distribution function is given. So one formula is to find smaller f of x. So smaller f of xi. In general, with the xi means the value of x it may be 1, 2, 3 like this. In general, I write xi. Whose formula is p of capital X is equal to small xi. So f of x or p of capital X is equal to small x, both are same. We already write that probability mass function symbol is f of x or p of capital X is equal to small x. And whose formula is f of xi, that is capital F of xi minus f of xi minus 1. That means the previous of that one. Suppose the value of x is 2 What is the lesser number of 2? We reduce by 1 is 1. Suppose 3 is there. 3 minus 1 is 2. 4 is there. 4 minus 1 is 3. So it is a general formula to find probability mass function. Suppose a cumulative distribution function is given. The formula is f of xi is equal to p of capital X is equal to small xi is equal to capital letter f of xi. That means the cumulative distribution function of the random variable xi minus whose previous value. Next, here also I give one example. Suppose the random variable x contains these three values 0, 1, 2. Suppose to find f of 2. That is f of 2. So p of capital X is equal to 2. We already know small f of x is nothing but p of capital X is equal to small x. So what is the formula? You see f of xi means first we write f of xi. So capital letter f of 2 minus by our formula minus f of 2 minus 1 xi minus 1 whose 1 less number 2 minus 1 is 1. So these are the important concepts regarding the second exercise. So all these formula or the concept you should memorize. You see all of our important formulas. So using these concepts and the formula we do some problems. Okay, now we move the second exercise. You see the first one. 3 fair coins are tossed simultaneously. We tossed how many coins is very important. There will be 3 coins. Now find the probability mass function for which the number of eggs occur. The important the number of eggs. Okay. To find the probability mass function. The probability mass function first of all symbol is small letter f of x or p of capital X is equal to small x. So to find that value, so in each and every probability mass function, the first step is to find the values of the random variable. It's the first step to find the number of values of the random variable. Next one, to find the probability of each and every random variable, then we form a table. The table indicates the probability mass function values. Okay. First of all, we write the sample phase. How many coins? 3 coins. In the previous class also we say, in coins are tossed, the general formula is 2 power n. Here 2 power 3, so 2 cube is 8. How to write the sample phase when 3 coins are tossed? We already tell. Start from H, H, H. Then H, H, T, H, T, H, T, H, H. 4 events is over. Next, start from T, T, T. Then H is moved, T, T, H, T, H, T, and last is H, T, T. So n of s value is 8. 1, 2, 3, 4, 5, 6, 7, 8. Next is important x. Here x denotes the number of eggs. You see, find the probability mass function for the number of eggs. So let x denote the number of eggs. We already assume the number of eggs is x. Then this x is called a random variable. Then x is a random variable which can take the values. So what is the least and last values of the random variable? This is very important. We tossed how many coins? 3 coins. We assume x is the number of eggs. So you tell one possible. We tossed 3 coins simultaneously at a time. Number of head is assumed. So I think one chances there is no head. Is possible? In all the 3 coins there is no head. Is a one possible. So this random variable x can take the least value is 0. Because in all the 3 coins there is no head. You tell one more chances. Out of the 3 coins, any one coin have head is a chance. So 1, then 2, 3. So these values of the random variables are very important. So the value of x is start from 0 up to 3. Why I not write 4? Because we tossed just 3 coins only. The maximum number of 8 will come is 3 only possible. So 0, 1, 2, 3 is the first step. So in all probability mass function, cumulative distribution function, the first step is to find the random variable values. The next step is to find the probability of each and every random variable values. So now we find the probabilities. First one, P of x is equal to 0. That is the probability of no head. For understanding first I write no head. To find a probability value, so P of x is equal to 0. You know, P of a formula is n of a by n of s. What is the total number of chances? First I write 8. No 8. In sample phase, without 8, how many events are possible? 3 8. 2 2 2. 1 1 1. You see this one is no 8. So in out of 8, this one is 1. So that value is 1 by 8. Where write P of x is equal to 0 is 4. Next, in the same way, we find P of x is equal to 1, 2, 3. Next, P of x is equal to 1. That is the probability of getting one head. In one head, how many events are possible? Here, 3, 2, 2, 2, no. You see, this one is one head. That event and this event. Total number of events? 1, 2, and 3. So, 3 by 8. Next, P of x is equal to 2. No need to write this one. This one is for your understanding. Then directly write the answer. P of x is equal to 2 means there will be exactly 2x. So exactly 2x, how many events are possible? 1, 2, 3. So 3 by 8. P of x is equal to 3. 3 8. 3 8, how many events are possible? Only 1. All the remaining condition just 2 or 1 or nothing. So 1 by 8. So the first step is to find the values of the random variables. The next one is to find the probability of each and every random variables. Next we form a table. So this function is called a probability mass function. Therefore the probability mass function is just we form a table. We form a 2 rows. And the first one is the values of the random variable. We write it is capital X or capital X is equal to small x. Then the probability mass function symbol is, we write small at f of x is enough. For understanding, I write f of x is nothing but p of capital X is equal to small at x. Then what is the total number of values of the random variable? Start from 0, 1, 2, 3. 0, 1, 2, 3. So 0, 1, 2, 3. Next, this one is whose probability values. When x is equal to 0, what is the probability value? When x is equal to 0, whose probability value is 1 by 8. When x is equal to 1, whose probability value is 3 by 8. When x is equal to 2, whose probability value is also 3 by 8. Again, when x is equal to 3, whose probability value is 1 by 8. So this all functions is called the probability mass function. This one is a simple example. Suppose we do our problem is correct or not. How to verify? We already tell in formula the total probability value is always 1. To add all probability values, to add all these probability values, that answer is exact will come 1, our answer is correct. You check to add all, you see all the denominators is the same, so whole divided by 8, numerator 1 plus 3 4, plus 3 7, plus 1 8, 8 by 8 is 1, so our answer is correct. So this is a way to find the probability mass function of any values. What is the first step? To find a probability mass function, the first step is to find the values of the random variables. The next one is to find the probability of for each and every random variable values. Okay, we move the next one. One table is already given. A random variable x has the following probability mass function. The random variable values and whose probability values, all values are given. The random variable value start from 1, 2, 3, 4, 5 and is given probability mass function symbol is f of x or p of capital X is equal to small t x. So in both the symbol, any one symbol is given. Whose values is given as k square, 2k square, 3k square, 2k and 3k. Then there will be 3 questions. The first one is find the value of k. Second one, p of 2 less than or equal to x less than 5. That is, the random variable value suppose can take the values of 2 and less than 5. And third one, p of x is, p of 3 is less than x. So to find these 3 values, first step is to find the value of k. We already tell the total probability value is always 1. So first using this concept, we know that summation of f of x value is equal to 1. The sum of all probability value is always equal to 1. That is f of what is the least value of x is given 1. So f of 1 plus f of 2. You know very well summation means to add all. So the first value of x is 1, 2, 3, 4 and 5. All values should come is equal to 1. So that means summation of all probability value is 1. Generally we write just a summation symbol. Summation of f of x is equal to 1. Or you write in very clear. So you write start from the value of x is 1 up to 5. And no need this step. So understand, just we write a summation symbol, then we add. Now what is the value of f of 1 is given. When x we substitute here 1, f of 1. The value of f of 1 is k square plus f of 2, 2k square, f of 3, 3k square, f of 4, when x is substitute 4 here, f of 4, that value is 2k plus 3k is equal to 1, okay, 2k plus 3k is equal to 1. Some k square and k term is there. First we add a k square term. 3k square plus 3k square is a 6k square plus we add some k. 2k plus 3k is a 5k. Suppose the plus 1 becomes that side minus 1. What is the reason I take plus 1 here minus 1? It is a quadratic equation. Coefficient of k square is also there. First we multiply. 6 into minus 1 is a minus 6. So we have multiply unit number, we get minus 6. At the same time, the coefficient of k is a 5. What is the chances? 6 minus 1. 6 into minus 1 is minus 6. 6 minus 1 is a 5. But coefficient of k square is there, so divide by 6. You know very well the denominator is the value of a coefficient of a k and numerator is a constant. Here both are 1. So k plus 1. And here denominator is a coefficient of k. So 6 is there. 6k minus 1 is equal to 0. So to write in factor form, either k plus 1 is equal to 0 or 6k minus 1 is equal to 0. Product of these two values 0 means any one it should come is equal to 0. When you simplify this one, the value of k is minus 1, and we simplify here 6k is equal to 1, so the value of k is 1 by 6. So this value of k is 1 by 6, and here the value of k is minus 1. I say the value of k is minus 1 is impossible. The value of k is minus 1 is impossible. Why? Because this k value contains some probability values. Here no problem, all are positive. Suppose we substitute here 2 of minus 1 is minus 2. Any probability value is possible in minus? No. All probability value lies between 0 to 1. So that's why minus value of the probability is impossible. This value of k is possible. So first one answer is 1. The value of a k is 1 by 6. Now we find the second summation. P of 2 less than or equal to x less than 5. This is the second one. P of 2 less than or equal to x less than 5. To find that value, the value of x is a 2 and also is less than 5. So in probability we find all possible values. So P of the value of x is start from 2 because the value of x is 2 less than or equal to x. So 2 or 3 or 4. So this value only possible. 5 not come because x value is less than 5. So P of x is equal to 2. For understanding, I write P of x is equal to 2 means f of 2. P of x is equal to 3 means f of 3. And that means f of 4. So what is the value of f of 2? The value of f of 2 is given. F of 2, when x is 2, f of 2 value is 2k square. So 2k square. Plus f of 3, when x is 3, f of 3 value is 3k square. plus f of 4, that value is 2k. 2. We already find the value of a k. So use the value of k here. The value of k is 1 by 6. 1 by 6 the whole square. 3 of 1 by 6 the whole square. Plus 2 of 1 by 6. 2 of 1 by 36. 3 of 1 by 36. Plus 2 by 6. There is a chance to cancel here. But I don't cancel. I take in the LCM. So no cancel the 6 one. Now you check what is the LCM of this all three values. Here 36, 36, 6. The LCM is 36. The first term already 36 is there. So just we write the numerator. 2 ones are 2. Plus second already 36 is there. 3 ones are 3. Plus the denominator is a 6, but our LCM is a 36. So you multiply 6 to 6, we get 36. So the wanted value of 6 is multiple to the numerator. 6 to 12. So you write 12. So what is the total value? 2 plus 3 is 5 plus 12 is 17. So 17 by 36 is the required probability value of the second solution. Now we move the third one. What is the third one to find? P of 3 is less than x. I write P of 3 is less than x in another form. P of x is greater than 3 also. Okay? We write in this form also. 3 is less than x or x is greater than 3. Both are same. So random variable x is a greater than 3 number to find whose probability value. So x is greater than 3 means it may be 4 or 5. So P of x is equal to 4 or P of x is equal to 5. Greater than 3 means it may be 4 or 5. Why not 6 here? Because the final value of x is just 5. So this two value is only possible. So this P of x is equal to 4 means f of 4. P of x is equal to 5 means f of 5. So f of 4, what is the value of f of 4 is given? When x is 4, f of 4 value is 2k. Plus, when x is 5, f of 5 value is 3k. To add we get 5k, 5 of, we already find the value of a k. 5 of, the value of a k is 1 by 6. So the required probability value is 5 by 6. So P of 3 less than x, or we write P of x is greater than 3. The value is 5 by 6. Okay students, now today we will see the important concepts of the discrete random variable, and also we do some problems. The same model sum lies in exam also. We must try in our class or not.